All right, we're going to get started with Unit 11, Section 2, and we're going to continue talking about similar figures, but we're going to add on to what we did in Section 1. So one thing to remember is that when we're looking at side lengths with similar figures, that the ratios are the same, and we look at the alphabetical order of the letters when we name figures to help us out when determining corresponding angles and sides. So we have triangle ABC is similar to triangle JKL, and we're looking for the side length JL. So I first know that side AB is 30. So I'm going to go ahead and write AB is equal to 30 over, and then I have AC here, which is 42. And what we're looking at is we're trying to find JL here. So I know that AB, that 30 is going to match up here with JK, which is 25. So I could actually write it as 30 over 25 equals 42 over JL, which is X. So now I just have a proportion, and I'm going to cross multiply and solve. So 30 times x, which is 30x, equals 25 times 42. And that ends up being 30x equals 1050. So now you just have a one-step equation solving for x. We're going to do the opposite of multiplication and divide both sides by 30. So when I do that, I have x equals 35, and our unit of measure here is feet. So we're going to make sure we add that unit on. So what I did here was I set up side AB, which is here, 30. That is set up a ratio with side JK, right? Because those are the same, so 30 over 25. And then we set that equal to side AC, which is here, 42, over our unknown side here, JL. So by setting up a proportion, we can find the length of JL to be 35 feet. We're going to do the same thing with number 2, however we're working with rectangles instead of triangles. So given PQRS is similar to WXYZ, we're looking for WX. So what I'm going to do here is I'm first going to look at side QR, which is here. So that side there. And we're going to set that equal to XY here, which is 44. And we're having that over PQ, which is here. And the corresponding side on the other side would be WX. Okay. We then fill in our measures. So QR is equal to 16 over 20 equals 44 over X. Now I just have a proportion, and I'm going to cross multiply and solve for X. And so when you do that, you will get the length of side WX. Again, use the letters to help you. So QR are our 2 middle letters. So we know that's going to be similar and equal to side XY. We then have PQ, so our first 2 letters. So then we know that has to be equal to WX. So when I set up my proportion, I set those sides equal to each other. And that will work for you. again, if you have any questions on this or how to set up your proportion, please ask your teacher. So let's go ahead and look at this word problem right here. Using indirect measurement, this is sort of a classic similarity problem. So it says a woman who is 64 inches tall is standing by a lamppost that has a height of 112 inches. So I'm going to go ahead and draw my woman here. And we know she is 64 inches tall and she has a shadow. Then we have our lamppost, and it also has a shadow, but its height is 112. So our shadow for the woman is 20 inches. So now we want to find the length of the lamppost shadow. So there's two different ways to do this. You can either set the height of the woman over the height of the lamppost equals the shadow of the woman over the shadow of the lamppost, or you could say the height of the woman over her shadow is equal to the height of the lamppost over its shadow. Either way that you set this up, you should get the same answer. So let's go ahead and use this one here. So we'll have 64x equals 20 times 112. That ends up being 64x equals 2,240. And when you divide both sides by 64, you have x equals 35 inches. So the lamppost shadow is in fact 35 inches. All right, continuing to the back page, we're going to use algebra to find the length of these similar triangles. So it says find the specified side length. So given triangle PQR is similar to triangle STR, we're looking for QT. So we're going to do this the exact same way. However, now we're working with an additional variable. So it may help to go ahead and draw the two triangles again. So this is my first triangle, PQR, and PQ is 25, and QR is x plus 18, because we have x and 18 that we need to add together for that whole side. And that is similar to triangle STR, and that base is 18 and this side is 15. So those are my two triangles. If we are looking for side QT, we're looking for what x is. So I'm going to say side PQ is 25 over the side length over the base, so 25 over x plus 18 equals our side length of our second triangle is 15 over 18. So then I just have our proportion where I need to solve. So I'm going to say 15 times the quantity of x plus 18 equals 25 times 18. When I do the math and use the distributive property, I get 15x plus 270 equals 450. I now have a two-step equation that I know you know how to solve. Subtract 270 from both sides. You're left with 15x equals 180. Divide both sides by 15. And x does in fact equal 12 meters. So the side QT equals 12 meters. I want you to do the same thing for number 2. I'm going to let you try that one. Again, it may help to draw your two triangles separately. And then after you solve that one, you have 3 review problems using multiplicative inverse and fractions, canceling fractions to solve. So again, if you have any questions, please don't hesitate to ask your teacher. Thanks so much.